Somewhere out past the orbit of Pluto, past the edge of everything we call home, there's a machine older than most people reading this, moving through the dark at 17 kilometers every second, carrying a message meant for someone who does not exist yet. Now ask yourself a question. Nobody at NASA wants to answer out loud. What happens the day that machine stops moving through empty space and starts moving through something else? What happens the day Voyager 1 hits ground? That is not a question about physics. Physics already answered it. At the density of matter between the stars, the odds of Voyager 1 striking anything solid are close enough to zero that engineers don't even model it. But this is not a question about odds. This is a question about what that impossible moment would actually mean if it happened. And once you sit with that question for more than a few seconds, you start to realize something uncomfortable. We built a machine, launched it away from us on purpose, and told it, in the coldest possible terms, that it would probably never stop. So what does it mean if it did? Let's start with what is real, because the fiction only works if you understand exactly how strange the truth already is. Voyager 1 launched from Cape Canaveral in September of 1977, a year when the most advanced computer most people had ever touched was a pocket calculator. It carries roughly 68 kilobytes of computer memory. Your phone has that beaten by a factor of 1,000,000. And yet this nearly 50-year-old machine is, right now, still transmitting, still listening, still, in some limited sense, still alive. By the end of 2026, Voyager 1 is expected to cross a threshold that no human-made object has ever crossed before. NASA calls it the 1 light day mark. It means the probe will be so far away that a radio signal moving at the fastest speed the universe allows will take a full 24 hours just to reach it. Send it a message on Monday morning, and if it answers immediately, you hear back Wednesday. 2 days round trip for a single sentence. NASA lists that moment for November 2026, when a radio command leaving Earth will need a full day to reach the spacecraft, with a reply needing another day to return home. Read that again. 2 days, not for a phone call across the ocean, for a whisper across the edge of the solar system. Space daily AOL. And here's where it gets worse, because edge of the solar system isn't even accurate anymore. Voyager 1 left that behind over a decade ago. It crossed beyond the sun's heliosphere in 2012, becoming the first spacecraft ever to operate in interstellar space, the region between stars, where our sun's wind no longer reaches, where the material drifting past the hull didn't come from our solar system at all. It came from other stars, other explosions, other deaths, billions of years old, scattered across a galaxy that doesn't know we exist. As of 2026, Voyager 1 sits roughly 25.5 billion kilometers from Earth, about 170 times the distance between Earth and the Sun, and that distance is not standing still. It grows by another 3.6 astronomical units every single year, more than 500 million kilometers, added annually, forever outward, never back. Space daily plus 2. Think about what that means for a machine built by human hands. It is not orbiting anything. It is not circling home. It is walking away from us permanently at a speed of about 61,000 kilometers per hour, toward a fixed point in the constellation Ophiuchus. And it will keep walking long after every person who built it, launched it, and is reading this sentence right now is dust. BBC Sky at Night Magazine. But the machine itself is dying too, just slower. It launched with 11 scientific instruments. 4 are still operating. Its power source, 3 generators that convert the heat of decaying plutonium into electricity, produced about 470 watts at launch. It now produces roughly 250 watts, and loses about 4 more every single year. By the spring of 2026, the ground team had been forced into a decision that sounds almost cruel when you say it plainly. They shut down another instrument on purpose to buy time. Engineers hope the sacrifice can keep Voyager 1 alive long enough for an upgrade nicknamed the Big Bang, one that might let the aging probe push deeper into space and possibly even resurrect some of the instruments they've already killed off. That is the real story happening right now, quietly, while almost nobody is watching. A team of engineers on Earth deciding which parts of a 50-year-old machine get to keep living and which parts have to die first, so the whole thing can survive a little longer. Space daily plus 2. This is the spacecraft we're talking about, not a ship, not a probe with shields and sensors like the ones in the movies. A slowly dying, slowly fading, nearly deaf and nearly blind machine running on decades-old code, 4 billion miles from anyone who could ever fix it if something went wrong. And now knowing all of that, ask the question again. What if that machine crashed? Not crashed like a car crash. There's no road out there. What we mean is this. What if, against every calculation, against every model of how empty interstellar space actually is, Voyager 1's trajectory intersected something solid, a planet, a moon, a structure, something with enough mass and enough surface to stop or catch or absorb humanity's most distant emissary? Here's where it gets worse. If it happened, we might not know for 2 days. Because remember the math. 1 light day out. A day for the command to arrive, a day for the answer to return. If a Voyager 1 struck something at the exact moment its onboard clock ticked over, the silence wouldn't announce itself immediately. There would be no alarm, no red light blinking in a control room in Pasadena. There would just be the next scheduled communication window, arriving on schedule, and then nothing. No signal, no confirmation, no error code. Just an absence where a heartbeat used to be. And that absence is the part that should genuinely unsettle you. Because a team of engineers has spent nearly 50 years learning to read every flicker, every dropout, every irregularity in that machine's transmissions like a language. Susie Dodd, the Voyager project manager at NASA's Jet Propulsion Laboratory, has described exactly what it's like to talk to something this far away. Sending a message Monday morning and hearing the reply Wednesday, every single time, forever. Imagine being the person whose entire job, for years, has been listening for a specific whisper from the edge of known space on a fixed and unbreakable schedule, and then one day, the whisper doesn't come back. Not garbled, not weak, just gone. Space daily. The first assumption wouldn't be alien contact. It would be failure. A power system finally dropping below threshold. A transmitter finally burning out after half a century of continuous operation. Most current projections already expect the mission to fade out sometime in the early 2030s, once the power supply drops below what's needed to run any remaining instrument at all. So the silence, at first, would look exactly like the ending everyone has been quietly preparing for since the 1990s. The natural death of an old machine, arriving a little earlier than expected. Nobody would leap to, it hit something. Nobody would leap to, it's not empty out there after all. Because the boring explanation is always the first one anyone reaches for. And for good reason, it's almost always correct. Space daily. But here's where the scenario stops being boring. Say the engineers do everything they normally do when a signal drops. They check the antenna alignment on Earth's end. They check for solar interference, for scheduling errors, for any of the dozen mundane reasons a signal might simply be missed rather than lost. And none of it explains it. The silence holds, not for a day, not for a week. It holds. Now think about what that kind of silence actually requires, physically, for a machine built the way Voyager 1 was built. This isn't a modern satellite that can lose power gracefully and drift, dark but structurally intact, forever. Voyager 1's radioisotope generators are still producing electricity, slowly decaying but still active, still capable of running the onboard transmitter as long as the hardware itself remains functional. For the signal to stop completely and permanently, something has to have physically damaged the transmitting hardware itself. Not drained it, damaged it. And in the vacuum of interstellar space, moving at 61,000 kilometers an hour, there's really only one category of event capable of doing that instantly and totally. Impact. Read that again and sit with what it implies. Because this is the moment the story stops being about a fading old spacecraft and starts being about a mystery with edges you can actually see. A collision at that velocity would not look like a car hitting a wall. Voyager 1 is a machine roughly the size of a small car itself, and it is traveling at a speed that turns even a pebble into a demolition charge. If it struck a surface, a planetary body large enough to be more than debris, small enough that its existence in that particular patch of interstellar space had never been detected from Earth, the spacecraft would not survive as a spacecraft. It would survive as wreckage, as scattered components, as essentially an artifact. And that is the exact moment this hypothetical stops being about NASA losing a 50-year-old probe and starts being about something far stranger. Humanity's first physical object, deliberately sent outward with a message attached, arriving somewhere. Not orbiting, not passing by. Landing, however, violently on the surface of another world. Think about what Voyager 1 is actually carrying. Because this is the detail that turns a technical failure into something closer to myth. Bolted to its hull is the golden record, a phonograph disc plated in gold, holding greetings in 55 languages, recordings of wind and rain and whale song, images of human anatomy, of childbirth, of cities, of a woman eating an ice cream cone, of the structure of DNA. It was assembled by a team led by Carl Sagan in 1977 under the assumption that the record's real audience would never listen to it in any of our lifetimes, might never listen to it at all, and might not be human when they finally did. Now picture the actual physical outcome of a high-velocity impact on unknown terrain. The record itself, gold-plated and built to survive nearly indestructible cosmic conditions, might endure the crash. The delicate instruments, the magnetometer, the plasma wave subsystem, the last surviving eyes and ears of the spacecraft, almost certainly would not. So what you would be left with, scattered across some alien surface, is not a working machine anymore. It's a wreck, a ruin. A piece of 1977 human engineering, broken open on ground no human has ever touched, holding inside it a golden disc that says, in 55 different human voices, Hello, we come in peace, we exist, please remember us. And this is where everything changes, because now you have to ask who, if anyone, would ever find it. Here's the part almost nobody talks about when they imagine alien contact scenarios. The assumption is always that they come to us. A ship arrives, a signal is received. Something announces its presence deliberately in a way we're built to detect. Nobody imagines it happening backwards. That the first contact isn't a signal we receive, but a wreck we leave behind. That somewhere, decades or centuries or millennia from now, something with the capacity to notice discovers the twisted remains of a machine that no longer functions. Next to a golden disk, it has no way to decode, and has to reconstruct an entire species from 4 scraps of broken metal and 45 minutes of scratched audio. Think about how impossible that reconstruction actually is. The golden record was designed with an instructional diagram etched onto its cover, showing, in theory, how to build a device capable of playing it back. The same way the record itself works, using a stylus and rotational speed keyed to the natural transition frequency of a hydrogen atom, a number assumed to be universal, understood by any species capable of interstellar travel. But that assumption requires an audience already advanced enough to understand hydrogen spectroscopy, patient enough to reverse engineer the mechanism, and curious enough to bother. It assumes intelligence. It assumes goodwill. It assumes, frankly, an audience nothing like what most abandoned wreckage on Earth ever receives from the animals that stumble across it. And this is where the story stops being comforting. Because the honest, uncomfortable truth about this scenario is that most likely outcomes are not first contact stories. They're archaeology stories, minus the archaeologists. A piece of debris sitting on a surface for a length of time so long that human units of measurement start to lose meaning. Not years, not centuries, but geological time, the kind of timescale where continents shift and stars die, with nothing nearby capable of recognizing it as anything other than rock or metal or noise. The most probable outcome of Voyager 1, physically striking another world, is not that someone finds it, it's that no one ever does. That humanity's most careful, most hopeful, most deliberate message in a bottle lands on a shore with no one standing on it, and stays there, forgotten, for longer than our species has existed. But suppose, for a moment, that someone is standing on that shore. Suppose the impossible odds, and they are genuinely, overwhelmingly impossible because interstellar space is so empty that even calling it empty understates it. Suppose those odds broke, once in exactly the way needed for Voyager 1 to strike a world that also happens to host something capable of noticing wreckage and understanding it as manufactured rather than natural. What would that discovery actually tell them about us? Not what we hoped it would tell them. Not the curated highlight reel Carl Sagan and his team assembled with such care in 1977. What it would actually tell them is the shape of the wreck itself. A machine built for one-way transmission, never designed to return, launched by a species willing to send a piece of itself outward with functionally zero expectation of ever hearing back. It would tell them about a species patient enough to build something meant to outlive its builders by tens of thousands of years. And it would tell them about a species anxious enough to attach an instruction manual to that machine, just in case, on the offhand chance that someone someday might care enough to listen. Think about what that combination actually says about us as a civilization, stripped of everything we intended it to say. Patience and desperation, welded together into one object. Hope, encoded as engineering. A message that says, essentially, we don't know if you exist, we don't know if you'll ever find this, we don't know if you'll understand a single second of it, but we built it anyway, because the alternative, saying nothing, reaching for nothing, felt worse than the odds against being heard. That is the real story most people are not seeing when they picture Voyager 1's golden record as some kind of interstellar greeting card. It isn't a greeting, it's a confession. It's the sound of a species admitting, on the record, forever, that it was afraid of being alone. Now escalate that thought one more step, because there is a darker version of this scenario that deserves to be said plainly rather than dodged. What if the world Voyager 1 struck wasn't empty and wasn't populated by anything patient or curious at all? What if the thing that eventually approached the wreckage wasn't an archaeologist or a scientist, but something closer to a predator or a machine of its own, built by a civilization with priorities that have nothing to do with curiosity? In that version, the golden record isn't a bridge. It's a liability. It's a detailed, freely offered blueprint of exactly where a vulnerable, technologically primitive species lives, what it looks like, how its body works, and roughly how advanced its engineering was as of 1977. Information handed over voluntarily, with no way to take it back, the moment contact is made. This is not a new fear. Physicists and philosophers have argued about this exact tension for decades, the same debate that shaped the entire discipline of searching for extraterrestrial intelligence. Do you announce yourself to the universe and hope for the best, or do you stay quiet and hope no one is listening for the wrong reasons? Voyager 1's golden record was, by design, the loud option. It was built and launched at a moment in history when optimism about first contact still outweighed caution about it. Nearly 50 years later, with the spacecraft's power failing, its instruments going dark one by one, and its silence in interstellar space growing louder every year, that original decision is still out there, irreversible, riding a slowly dying machine toward a fate nobody can predict and nobody can call back. So follow the story to its natural endpoint, because this is where the uncertainty stops being comfortable and starts being the entire point. Nobody, not NASA, not the engineers managing Voyager's slow decline, not the physicists modeling interstellar density, actually expects a collision. The math overwhelmingly says the spacecraft's most likely ending is quiet and undramatic. A gradual loss of power sometime in the early 2030s, instruments falling silent one after another until the transmitter itself finally has nothing left to send with. That is the boring, almost certain answer. And yet the boring answer isn't the one that keeps mission scientists talking about the spacecraft in tones usually reserved for aging relatives. Dodd and her team have spoken openly about wanting the twin Voyager probes to reach their 50th anniversary in 2027, the way you'd talk about someone you're hoping makes it to one more birthday. That's not the language of routine engineering. That's the language of people who understand, on some level, that they are managing the final years of the most extraordinary object humanity has ever built. An object that will keep moving in total silence for millions of years after it stops talking to us, regardless of whether it ever hits anything at all. Space, daily or all. And that's the detail that should actually keep you up at night, more than any crash scenario. Even in the version where nothing ever strikes it, where Voyager 1 simply drifts forever through the black, unchanged and untouched, it never really stops. It just stops talking. The machine keeps moving at 61,000 kilometers an hour, carrying its golden disk, its greetings in 55 languages, its whale song and its diagrams, and its unbearably human hope of being found, forward into a darkness with no destination and no deadline, for a length of time so long that the sun itself will likely have changed before Voyager 1 encounters anything solid enough to stop it. So what does it mean if it did crash? What does it mean if, against every calculation, somewhere out past anything we can currently detect, that machine's outward march finally ends against a surface instead of dissolving into permanent silence? It would mean humanity's longest sentence, spoken in 1977 and still being spoken today, finally reached a period. It would mean the loneliest object we've ever built stopped being lonely, one way or another, either by being found or by finally, physically, landing somewhere real. And it would mean that somewhere out there, on a surface no human eye has ever seen, sits a small, broken, golden-plated fragment of who we were, patient enough to build it, hopeful enough to launch it, and honest enough, in the end, to admit that we sent it outward not because we knew anyone was listening, but because we couldn't stand the thought of staying silent. We may never know if it happens. By the time any signal confirming it could possibly return to Earth, the spacecraft itself will likely be operating on nothing more than a plutonium ember. The truth is, we built a message for a future so distant it has no name yet, addressed it to a listener we have no evidence exists, and sent it walking into the dark alone. It is still walking right now as you read this, 4 billion miles out, silent for the next full day between every word it manages to send home. Somewhere out there, its road either ends or it doesn't, and nobody, not NASA, not the physicists, not the engineers who still say good morning to it every week, knows which.